Hello and welcome to this short introduction to machine learning APIs in Apache Spark. Why would you want to use Apache Spark for machine learning? First of all, for data preparation. Data preparation takes a large fraction of the effort in a machine learning project. I refer to this drawing in the slide from a paper by Google in 2015, where they demonstrated that the actual running of machine learning code takes a small amount of effort compared to other tasks that are around and very important in the ecosystem of the machine learning projects. Spark can run data preparation at scale. We have seen the data frame API in previous lectures of this course, and feature preparation and data ingestion, data preparation and data exploration and cleaning of the data can be done at scale and in a fault-reliant manner using Spark. Then Spark can scale, for example, hyperparameter search, and can scale training, as we will see in this lecture. And also Apache Spark has familiar APIs similar to popular tools in this domain, in particular scikit-learn. The typical steps in a machine learning project will start with the exploration of the dataset, then preparing data for machine learning algorithms, so feature engineering and feature preparation. Then there will be model development, experimenting with different models, and then finally tuning the hyperparameters, and then training the model, testing and evaluation, and defining performance metrics and measuring the performance of the model. And an additional step is moving the model in production and do inference on the model with the new data that comes into the system. So Spark APIs that can help you in this domain are the Spark data frame and SQL that you can use to explore your dataset, prepare data for machine learning algorithms, and do feature engineering. Then there is the API Spark.ml that you can use for feature engineering again, and feature preparation, searching for the best model for your problem, training and validation, and also inference. The Spark.ml API works with the data frame API, so you will have data sources. Let's say there could be a DB, or could be a file data source, CSV, JSON, Parquet. We'll do pre-processing, cleaning, and feature engineering using the data frame API and using the Spark ML API, which has specialized functions to do that. In particular, there will be transformers and estimators that we will define later that you can use to prepare your data. And then you can use that to train the model and tune the model. And finally, to do evaluations, and this ends at least the first stage of the project. Typically, you will then feedback and do a second round. Some key components of Spark ML. Data frames are ubiquitous in Spark, so we'll use that as the main API for data processing. Then Spark ML has two different categories of operations. One is transformers. These are algorithms that transform a data frame into another from input to output, and they all have a transform method. Then other operations are estimators. These are algorithms that build custom transformers based on data, and they have a fit method. When you train, you fit the data, for example, to create a model, you will use an estimator. Pipelines are also important objects that allow to put together multiple processing steps. You use them to build machine learning workflows composed of transformers and estimators. A pipeline itself is an estimator. So key step, an example. This is creation of a pipeline. So we'll import the pipeline from PySpark.ml, so we're using the Python API here. The pipeline prepares the features and feeds them to a model. So the pipeline allows to put together multiple stages of multiple transformations, for example. And then the pipeline can be used to fit to the training data sets. So we take the data. Let's say the input data is in a data frame that we read from some file source. It's typical in this domain is to split the data into a training and test data set. Often one uses three data sets: training, validation, and test. For simplicity, we just here use training and test, and we split 80% and 20%. The 80% is training. So the model transformer will be the pipeline dot fit training data. So we take the training data and we fit them to the pipeline. The pipeline defined above contains multiple stages. We'll see the details of how this can be built in the following and also in the demo. And the final results of fitting the training data into the pipeline is to have a model, which is a transformer. And then we can use the model against the data sets, for example, the test data set. So the predicted data is model transformer dot transform. So the model is a transformer on the test data. Test data being defined from the split of the original data into 80% training and 20% test. So what we want to do with model training? First of all, we have two broad categories of supervised learning models. So we stick here to supervised learning. There is also another category of machine learning that we're not covering in this lecture, that is the unsupervised learning. And on the supervised, we have classification problems where we want to predict a label, and regression tasks where we want to predict a quantity. So regression, you can think of it as a fitting a line to a set of points, and classification to define, let's say, two categories, blue and red, for a bunch of points. So when we have the training data, we want to use that to fit a model. So this means finding a complex functions that we learn from data that we use to characterize the input. So this function, when it works and everything works well, is supposed to be able to generalize on new data and understands from new data how to either predict a label if it's a classification or predict a quantity if it's a regression. At this point, the details are in a separate notebooks, and there is a video on the running machine learning with Spark for this notebook. I refer you to that. You can jump to it and come back to this one later on. I would like now to just comment on Spark and deep learning. Deep learning techniques are very popular and very powerful these days for many tasks like vision and also language processing. Spark has definitely a role into that. First of all, it can be used for data preparation at scale, and once data is prepared, it can be saved into format like Parquet or TF record, which is a format used by TensorFlow or other formats, and then one can read data prepared using Spark, using one of those tools specialized for deep learning. It's also possible to run TensorFlow and PyTorch on GPUs if you're at CERN, and then you will read the data prepared with Spark. This is where you get the information now to run GPUs, notebooks using this one service if you are a CERN user. Then going back to the mainstream Spark, there are also third-party tools that integrate Spark with TensorFlow and PyTorch, which are currently some of the most used tools for doing deep learning. I would like to mention Horovod and BigDL. This domain is in constant evolution, so you can check the latest news there. This brings us to the final slide of this short lecture, the key learning points. Spark can be used for data preparation at scale for your machine learning projects. You can profit of the Spark Data Frame API to read and process data, and it allows you to process from different data sources, different data formats, different storage systems. It's very flexible, you can run at scale and in a fault-tolerant manner, as we have seen in the lectures on data frames and Spark SQL. Then Spark, specifically for machine learning, has libraries that you can use to scale machine learning training and this you will scale on clusters like Hadoop or cloud resources with Kubernetes, and you can also scale hyperparameter tuning. And then you can use Spark Data Frame API and Spark UDFs on data frames to do model inference if you need to. And this ends this short lecture.